Hello, good morning, students. How are you all doing? Hope you're all doing fine and hope you're all doing absolutely great. So, in today's video in mathematics, we'll be talking about the operation with sorts. So, previously we have talked about indices, we have talked about logarithm. Now, today we'll be talking about sort. You see, these three aspects of algebra is very important in understanding the concept of algebra itself before we can move into complex aspect of mathematics. These are the basic ones that we have to teach you, especially in your introduction as a foundation of senior secondary school mathematics. Very important for you to understand this. You see, let me just start with a particular statement. If some numbers are expressed in ratio of two integers, example, what I mean by integer are set of values that it is not equals to zero. You understand? I'm talking about one, two, three. And when I said ratio, it means something divided by something. So if some numbers are expressed as a ratio of two integers, for example, 3, 2 over 5, 3 over 6, 7 over 8, and so on like that. This is the meaning of ratio. You know, this 3 is same thing as 3 over 1. So it's same thing. This one is same thing as 2 ratio 5. This one is same thing as 3 ratio 1. This one is same thing as 3 ratio 6. This one is same thing as 7 ratio 8. So if you express a particular number, like two numbers, as a ratio of each other like this, we call them rational numbers. I get what I'm trying to say. We call them rational numbers. You see, other numbers that we cannot express as ratio of integers, that we cannot express as ratio of integers, we call them irrational numbers. And the reason why we call them irrational numbers is because we cannot state their exact value. You understand? We cannot really say their exact value. We can only approximate values. For example, now pi. You know, the approximate of pi is 3.142, right? Exponents. You understand? Like that, like that. So you see, Sod is an irrational numbers, or let me say sorts are irrational numbers. They are roots of rational numbers whose value cannot be expressed as exact fraction. I get what I'm trying to say now. So example of sorts are root 2, root 17, root 32, root 18, and so on like that. These are sorts. So whenever you hear the word sorts, just know that we are dealing with what? We are dealing with concept of roots. You understand? Now we now have rule of sorts. We have rule for sorts, and I will be mentioning some rules that will be applying in this particular class. So the rule one, you know that indices have rules, logarithm also have rules. Though there is a particular complex aspect of logarithm, quite complex but simple, where we have law for logarithm as well. Apart from the logarithm that I've taught you, we have laws for logarithm. Then we'll be having log a multiplied by log b give us log a plus log b and stuff like that. You understand? But we are not there yet. So let us just face the one that we are actually dealing with. So the one that I want to teach you now is what is the rules of sorts. Rules of sorts. That's what I want to teach you now. So rule number one is that you see roots p multiplied by roots q equals to root of pq. That's the first thing you have to note. Root p multiplied by root q equals to root of pq. Now, another one is root p divided by root q equals to root of p upon q. That's the second one. The third one is root p plus root q is not equals to, it is not equals to root p plus q. You get what I'm trying to say now? It is not equals to root p plus q. And also, root p minus root q is not equals to root p minus q. So these are the four rules that I will be mentioning in this particular. So these are the basic rules for sort. You understand? These are the basic rules for sort. So let us take for an example. Let us apply the first rule. What is the first rule again? That is root p multiplied by root q equals to what? Root p multiplied by q, or root pq, which means if we have root 12 multiplied by root 3, that is equals to what? That is equals to root 12 times 3. That's equals to root 12 times 3, and that will give us what? Root 36. And if you should press your calculator, root 36 equals to what? Root 36 equals to 6. Also, we can actually apply the law of indices here. You might be wondering, how is root 36 equals to 6? You press your calculator, you get the same answer. But we can apply the law of indices here. Remember, I told you that whenever you see root, for example, root a, the same thing as a raised power what? A raised power 1 over 2, right? Which means the same thing as what? 36 raised power 1 over 2, right? Now, this 36 is the same thing as what? 36 is the same thing as 6 raised power 2, right? So I can write this as what? This 36, I can write as 6 raised power 2 multiplied by 1 over 2. So 2 cancel what? 2 cancel 2, and I'm left with 6 raised power 1, and that will give me what? That will give me 6. But the best thing you can actually do for yourself is what? Press a calculator and you get what? Root 36 equals to 6. You understand? Now, the next one is, let us say root 7 divided by root 2. You see, is the same thing as what? Is the same thing as root 7 over 2. As simple as that. You understand? So that is the basic aspect of surd. And let us now go to the basic form of surd. The basic what? The basic form of surd. Now, the basic form of surd, the first one I will be doing now is, let us say we have root 18. We want to simplify. Let us say they say simplify root 18. One thing about mathematics is that if you should press this root 18 in your calculator, you'll be having, let me open my calculator here so that we can actually work with it together. Let us press our calculator, and we are having root of what? We want to know the root. Where is the root here? Square root of 18 in this place. Square root of 18. Square root of 18 equals to 4.246. Now, you're told to simplify. You cannot write it for them in the exam that the answer is 4.24. So you don't need calculator in this case. You understand? You don't need calculator. How are you going to do it? You just think, okay, this 18, we can split it into two. What are the factor of 18 that we have? The factor of 18, we have 18 and 1. You understand? We cannot use this. We have 9 and 2. Yes, we can use this because 9 multiplied by 2 equals to 18. Which means I can say this is the same thing as what? This is the same thing as root of 9 multiplied by 2. Still the same thing, right? Now, remember I told you that root p multiplied by q is the same thing as what? Is the same thing as root p multiplied by root q, right? Therefore, I can say this is the same thing as what? Root 9 multiplied by root 2, right? So press your calculator. What is root 9? Root 9 equals to 3, which means it's the same thing as 3 multiplied by root 2, which is the same thing as what? Which is the same thing as 3 root 2. As simple as that. Can you see how simple it is? So very, very simple. So let us proceed. Let us say you are given something like let us take another example. I'm trying to look for another example here. If I should get one, I will let you know. Let us say you have root of I'm coming. I'm looking for examples here, please. Let's say root of 50. Yes. Simplify root of 50. Very, very easy, right? Because you can just split it into 2, and your factor is 25 and 2, right? So you can say the same thing as what? The same thing as root of 25 multiplied by 2, which is the same thing as what? Which is the same thing as root of 25 multiplied by root of 2, which is equals to what? Which is equals to, what is root of 25? If you press in your calculator, it's equals to 5, which means your answer is 5 what? 5 root 2. As simple as that. Can you see how simple it is? So that is just the basic aspect of surd itself. You understand? So let us proceed. Let us proceed to the next thing. So the next thing we want to move to now is what we know as the conjugate surd. The what? The conjugate surds. Let us take for an example. We have something like Let us say we have something like root x plus root y into bracket root x minus root y. This is very, very important, especially when we are dealing with rationalization. We soon get to rationalization. You get what I mean by that now. Now say you should simplify it, or let me say they say you should expand this particular bracket. You should open this bracket. So what you're just going to do is what? Root x times root x. It will give you what? It will give you root x squared, right? Root x squared. Now, root x times root y, it will give you what? Look at this. This is plus. The plus is here, right? That's plus root x, right? So multiply by the minus that is here. It will give you what? It will give you minus root xy, right? Now, root y multiply by root x. After you use this one to multiply the both here, you now use this one to multiply the both here. So root y multiplied by root x is what? Is plus root x y, right? Now root y multiplied by root y will now give you what? Plus minus root y squared. So what is going to happen here is that this one will cancel out this one because root will cancel out square. This one as well, root will cancel out square. Now plus xy minus xy will give us 0 because minus 2 plus 2 equals to 0, minus 3 plus 3 equals to 0, and so on like that. So minus xy plus xy will give us what? It will give us 0. Therefore, we'll be left with what? This one cancel out each other. We'll now be left with what? We'll now be left with x minus y, right? And that is our answer for this particular one. Now, you see, in general, the conjugate in this one is just x root x plus root y. You understand? So that is just the conjugate. Now, that is, I'm just giving you preambles. We are still going to do more this thing. So let us go to simplification of sort. Simplification of sorts. That's next that we want to go to now. So let us take the first example. I think we have already done this one already. Let us take the first example. Do this one by yourself. 45 root of 45. Question number 2, root of 98. Let us say they say you should simplify this. How are you going to do it? I can just pause the video before I solve this. It's actually very, very simple. Very, very simple. What are you going to do? For this root 45, remember that 45 is the same thing as 9 multiplied by 5, right? 9 multiplied by 5. So which means I can write this as what? I can write this as root of 9 multiplied by 5, right? 9 multiplied by 5. And 9 multiplied by 5 is the same thing as what? Is the same thing as root 9 multiplied by root 5. Which is same thing as what? Root 9 equals to 3. That's the same thing as 3 root 5. You can solve this 98 the same way, right? You can solve it the same way because 49 multiplied by 2 equals to 98, which means we can say this one is same thing as root of 49 multiplied by 2. So this is same thing as root of 49 multiplied by root of 2, which is the same thing as what? The same thing as root 49 equals to 7. So that will give us 7 root 2. So it's very, very simple, like quite easy. So I'm going to give you an assignment now for you to work on. The first one is root 8. The second one is root 60. The third one is root 240. The fourth one is root 200. And the next one is, the fifth one is root 50. So try to work on these ones. Try to work on these ones, and we'll try to proceed after then. Now, let us now talk about addition and subtraction of sorts. So we have talked about the simplification of sorts, and I hope you understand now. So let us talk about the addition and subtraction of sorts. You see, only sort in the same basic forms. I repeat, only sorts in the same basic form can either be added or subtracted. Sometimes there may be need to simplify such sort before doing either addition or subtraction. I repeat, only sort with the same basic form can be added or subtracted. Now, what if you are given a sort that doesn't have the same basic form? Therefore, you have to simplify such sort before adding or subtracting. You understand? Let us take for an example, our first example, root of 32 plus 3 root 8. You're not told to simplify this. Very, very easy. What are you going to do? Look at this, solve it, should I say separately. This one, you can say, this one, you have the factor to be 16 and 2. And this one, the factor is 4 and 2. 4 and 2. Which means I can write this whole equation as root of 16, or I can say root of 16 multiplied by root of 2 plus 3 into bracket root of 4 multiplied by root of what? Root of 2. I get what I'm trying to say now. Now, what is the next thing? What is the root of 16? Root of 16 equals to 4. You can press your calculator for that. That is 4 root 2 plus, what is root of 4? That is 2. That is 3 into bracket 2 root 2. I get what I'm trying to say now. Now, 3 multiplied by 2 equals to 6, which means I can write this as what? I can write it as 4 root 2 plus 6 root 2. Now, I forgot to mention something the other time. Whenever you have to add something like this, like whenever you want to add something like this, you have to understand there is one particular law that says that, for example, a root n and b, sorry, and and b root n, it will give us what? It will give us a plus b root n. Please, you have to note that. You see, this n will remain unchanged as long as these two n are the same. You understand? Because in this case, root n equals to root n. But if they are not the same, if they do not have the same basic form, then you cannot add them together. You understand? So in this case, this is 2 and this is 2. So this 4 will represent a that is here. This 6 will represent b that is here. And this root 2 and root 2 will represent what? It will represent this n and n that is here. Which means the answer for this particular question equals to what? Equals to 4 plus 6 root 2. You won't say 4 plus 6 root 2 plus 2. No. You just take only one of the root 2. Which means my answer here is 10 root 2. As simple as that. You understand? Let us do another question so that you understand it better. Let us say, for an example, you're given a question like 7 root 3 minus root of 75. You see that this root 3 cannot be separated. You can only separate this 75. And 75, you can say 75, this thing is 25 and 3, right? Which means you can say root of 75 multiplied by root of 3 minus 7 root of what? Root of 3. You understand? And what is root of 25? That is 5, which means it's the same thing as 7 root 3 minus 5 root 3, which means you can easily do this one like that. You can just say it's the same thing as what? It's the same thing as 7 minus 5 root 3. And that will give us what? That will give us 2 root 3. You understand? And that is our answer for this particular one. So let us do another one. Let us quickly do another one. Let us say we are given question like 3 root 48 minus 75 plus, sorry, root 75 plus 2 root 12. Now, what are we going to do? This one is quite easy. What you're just going to do is simplify it. Simplify each of them. Now, what are we going to do? Look at this 48. 48, I can multiply 24 and 2. I'll be 24 times 2 equals to 48. But is there root 24? No. Is there root 2? No, which means I cannot use it like this. What again can I use? I can use 16 and 3. Yes, 16 and 3. So let us use 16 and 3. You understand? Now for this one, I think I've done something like that here. That's 25 and 3, Abby. So this one, 25 and 3. 25 multiplied by 3. So this one is what? Is 4 multiplied by 3. You understand? So what are you going to do? Multiply. Just put the root at there. Put the root here. 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 You're going to have 3 here. You're going to be having 2 here, right? So I just write the whole equation. So what's the next thing I'm going to do? What is root 16 equals to 4? So I'm left with what? 3 multiplied by 4 root 3, right? Minus, what is the root of 25? That is 5. 5 root 3 plus, what is the root of 4? It is 2. That is 2 multiplied by 2 root 3. You understand? Now, 3 times 4 equals to what? Equals to 12. That is 12 root 3 minus 5 root 3. Now, 2 multiplied by 2 equals to what? Equals to 4 plus 4 root 3. Now, what's the next thing you are going to do? You have 3, 3, and 3. So, you are going to take only one of them, which means your answer will be equals to what? That's 12 minus 5 plus what? Minus 5 plus 4. Then root 3. So 12 minus 5 equals to 5 minus 4 equal 5 plus 4, right? Yeah, minus 5 plus 4 equals to minus 1. And 12 minus 1 equals to 11. Or you can even say 5 minus 12 minus 5 equals to 7. 7 plus 4 equals to 11. So my answer here is 11 root 3. As simple as that. Can you see how simple a sort is? So that is how to what? That is how to add and how to subtract in sort. You understand? Now, let us now go to multiplication and division in sort. I repeat, multiplication and division in sort. You see the first two rules on sort explain either of this section. It explains multiplication or division. Remember this thing that we have here. Look at it. We already have it here, right? We already have it that the first two, this is the first rule, this is the second rule. This one represent, this one explain multiplication, and this one explain what? It explain division. So let us quickly do a particular question. Look at this question here. Let us say they say you should simplify 45 multiplied by 28. This is what they ask you to simplify. Quite easy. What are you going to do? What are you going to do in this case? So what you're going to do is, I think I've done something of 45 before. I think 45 is 9 multiplied by 5, Abby? Yes, yes. 9 multiplied by 5. And 28, 12 multiplied by 2. Yeah, 14 multiplied by 2 is 28. No, we can't use that. 4 multiplied by 7. Yes, 4 multiplied by 7. 4 multiplied by 7 is 28. Yes. Now, what are you going to do? Put the root there. Put the root there. I get what I'm trying to say now. Now, what's the next thing? What is root 9? That is 3. Abi? That's 3 root 5. Multiplied by what? Multiplied by, what is root 4? That is 2. That's 2 root what? 2 root 7. What are you going to do? You see this one, they don't have the same basic form. But since it is multiplication that is in between them, you can actually do it easily. You will just multiply the ones outside the roots and the ones inside the root together. So that will be equals to what? That will be equals to 3 multiplied by 2. Root of what? Root of 5 multiplied by 7. As simple as that. And 3 multiplied by 2 equals to 6. That will be equals to what? 6 root 35. I get what I'm trying to say now. And that's your answer. As simple as that. That is your answer. Very, very simple. Let us do another question. Let us say we're given question like let's say we're given question like roots roots 24 over 50. Root 24 over 50. This is the question that we are given. This is the question that we're given. Can you try to solve this question? Can you try to solve this question? So this question is quite easy. This question is quite easy. We can first divide them. 2 here 12, 2 here 25. I'll be left with what? We'll be left with root of 12 over 50. Root of 12 over 50. Now we can now simplify it now. What is root of 12? You can say root of 12 is the same thing as what? It's the same thing as 4 multiplied by 3 divided by root of 50 is what? Root of 25. Sorry, I'm sorry. That's 25 rather. 25, not 50. 25. So that's root of 25, right? And that will give us what? What is root of 4? That's equals to 2. That's equals to 2 root 3 divided by what? Root of 25. That's equals to 5. Which means my answer in this case is 2 over 5 root 3. And that's how simple sort multiplication and division is. Can you see how simple it is? So I'll be giving you a question. I'll be giving you some question um in this particular aspect very soon. So the next one we'll be going to after this particular video is the rationalization of sorts or sort rationalization, and that will be on the next video. Thank you.